Hello everybody, my name is Ansu and today we're gonna make a proximity sensors. Well, if you know about proximity sensor, like what is that, then that's very good. If you don't know, then I'll tell you. You might have seen smartphones you might be having, or your friends might be having. There are two holes in the front of the smartphones. Like other than front camera, there are two other holes. So what is the work of two holes is, sometimes there is only single hole. I mean, there are two tiny holes in that single one. Well, the work of that hole is, one is transmitter, another is receiver. The transmitter keeps on emitting light and the receiver keeps on. So it's the kind of proximity sensors. Like as soon as we pick up a call and we take the phone to our ears, the light of the touchpad goes off. And as soon as we pick the phone with the front, light goes on automatically. We don't have to switch the light on and off. So how does it happen? It happens because of proximity sensors. The phone in form of two holes is having proximity sensors, which senses the presence of any layer in front of the phone, and the light goes automatically off. So this is the application, the main application widely used in everywhere of proximity sensor. Other than that, you might have seen the application of proximity sensor in escalators, in taps, automatic tap and all. Other than that, parking system and all, like there are lots of applications of proximity sensors. So today I'm going to tell you how to design your own proximity sensor, which could be useful several applications. Okay, so we are going to design proximity sensor using this is a breadboard used for electronic design, circuit design purposes. These are having lots of holes like a bread. So there are 4 layers, mainly 1, 2, 3 and 4. Okay, so there are lots of holes. In those 2 layers the connections are similar, like there are 4 holes in a single column. Okay, so all the 4 holes in a single column are interconnected, internally connected, but all the columns are horizontally disconnected. Okay, like this first column and second column are not connected. Similarly third, fourth and goes on. But in upper and lower layer, the holes are horizontally connected but vertically disconnected. Okay, similarly the group of 5 holes are there. So group of 1, 2, 3, 4 and 5. These 5 holes are connected internally and these next 5 holes are connected internally. So but those of 2 are not connected, they are disconnected. So now we are going to learn how to make a circuit on a breadboard. So wait a minute, I'm going to tell you how to make a proximity sensor using this breadboard. So we're going to design a proximity sensor using this breadboard. So first let's connect the wool line over here and over here, because what we do in normally breadboard connection is we connect this wool line so that we can use as a VCC or as a positive terminal or as a negative terminal. So we're going to connect one of this line and one of this line totally connected. Okay, what we'll do is we'll connect these two. Okay, did you got it? How do we connect it? Okay, is it okay? Now similarly this side too, I'm using this side as a positive, so I have connected a red wire, and this side I'll use it negative, so I'll connect a black wire. Can you see it? Can you see it? Now one red wire, one black wire. So those 2 wires are connected to the wool line in this and in this, in this and in this, in this and in this. So the wool line is connected here too, and the wool line is connected here too. The lower line, the upper line here, the lower line here. Okay. So this is a circuit diagram that we are going to use for designing proximity sensor. You can see here the first step. This is IR LED, right? IR LED emits IR radiations that you cannot see from naked eye. You can see it through camera, right? So we are connecting the positive pin of IR LED to the 5 volt and negative to the resistor and then to the ground. Second thing, this is a photodiode. This is a receiver. IR LED is the transmitter. It works as TX. Photodiode works as RX. This is a receiver. It works on the basis of amount of light falling on that. As soon as the amount of light falls on that, the resistance of the photodiode decreases rapidly. So it induces a voltage drop across it. That voltage drop is being compared with this preset. This is a preset of 20 kilo ohm. This preset, the voltage generated over here is compared by this via this operational amplifier IC. Here operational amplifier IC LM358. The first there are two operational amplifiers in LM358. The first one works as a comparator over here. It compares the two voltages, the first one this and second one this. As soon as this voltage increases from the certain fixed level of this voltage, this operational amplifier induces a positive 5 volt. I'll repeat again. As soon as voltage across the photodiode increases, when it will increase when a light will fall on that. As soon as the light falls on this photodiode, the voltage induces, and the voltage will increase than this operational amplifier will give a positive 5 volt. If it will not increase, then this will give negative 5 volt, I mean 0 volt. So ultimately this senses the amount of light falling on this photodiode, right? So as soon as any layer or any article or anything comes in front of those two holes, light from the transmitter reflects from that layer or that particle or that thing and falls back on this. So as soon as light falls on this, it induces voltage, and ultimately that voltage is compared by this operational amplifier, and at the end this operational amplifier gives plus 5 volt voltage, which just blows this LED, right? There's an LED, you can see clearly. So it blows this LED. So this LED is connected to the first pin number of LM358, and then to the ground, here. There's a 220 ohm resistor. Resistor used over here is 220 ohm. Over here it is 1K, and over here this one is a preset of 20K. So let's start making a proximity sensor using that breadboard and that circuit. So first of all, for designing any circuit, any of the project in breadboard, what you need is a power supply. So here we are having a power supply of this. One is red and one is black. You can see clearly over here. One is red and one is black. Red one is positive and black one is negative, right? So we are going to use this, but this is 9 volt power supply, and for normally digital circuits we need a 5 volt power supply. So we're going to convert this 9 volt into 5 volt, right? So how can we do that? How we are going to do that? We are going to do that using this IC. This LM7805 IC. 7805 means it converts last two digits are 05. It means it converts any voltage, any input voltage, digital direct current, into 5 volt. So what I did is, this is the breadboard. What I'll do is, normally all the ICs that are having a single line, this IC is having single line, right? So you can use it anywhere, right? So how we're gonna use it is like this way, because if you connect it this way, okay, so we are connected this way, you can see we have connected it this way. Now all the three columns are different and internally disconnected. The columns are internally disconnected, but the holes are connected. So in front of this hole, in front of this column, if we use another hole, then we can connect that wire with this in the backward hole and the VCC in the forward hole. So now the connection of adapter to 7805 is done. The negative connection of 7805 to the breadboard is done. The positive is remaining. So for that you're going to use this wire for connecting the positive, the output of this 7805 to the breadboard. We're going to use this wire and we'll connect the output of 7805. We'll connect the output of 7805 to the breadboard. So this is done now. So now the connection of power supply is done. So now we are going to work on the proximity sensor right now on this side of the breadboard. Right, we can work on any side, but right now we are going to work on this side. So we're going to use first of all the first step, and the first step is what? It is the IR sensor. So this is IR sensor, this is IR LED. You can see it glowing only in camera, not with naked eyes. Okay. So we'll connect this IR sensor over here. So here we are connected. Now we'll connect the ground. Now I'll connect the ground via resistor to the ground part. So now this is done. I have connected the ground via resistor to the ground part. Now to turn off positive. Now I connected the positive. Now I have connected the positive terminal of the IR LED to the positive one. So the work of IR LED is done. That is the work. The first step is done. Now the second is, this one is TX. Now second what we need is RX. So this is a photodiode. Photodiode is normally a diode in which the resistance changes according to light falling on it. As soon as the amount of light falls on it, the resistance goes on decreasing with increase in light falling on that. So we're going to use this light now. So we are going to use this now. Well, one more thing. This IR LED is used in forward biased mode, whereas this one is used, the photodiode is used in reverse biased mode with ground. So using this resistance, I have connected the positive terminal of this photodiode to the ground, and next the negative terminal. Using this wire, I'll connect the negative terminal. So now this is done. I have connected both the terminals of TX and RS to positive and negative as well, irrespective of what it should be connected. Now the turn off third stage, that is this preset. This is called preset. It is having 3 terminals. These two are positive and negative, and this one is output. So as soon as we move this, the resistance goes on changing. This white tab. See it. So I'm going to use this right now. Now I have connected both the terminals of preset to the positive and negative respectively. Now what I'm going to do is, I'm going to use this IC now. This is LM358. It is having 8 pins, right? So it is having overall of 2 operational amplifiers, one with 3 pin, another with 3 pin, and rest of the 2 pins are for VCC and ground. So I'm going to use this IC. Remember one thing, always in a breadboard use ICs in the middle one. One legs another side in the second layer and one other leg in third layer, like this. So this is the way that we have to connect the IC. Now what to do? Very first step for the IC is connect his VCC and ground with whatever it is. So I'm going to connect this ground. So I connected this ground, the ground of IC with the ground of breadboard. Here I have connected the 8th pin of the IC to the VCC and 4th pin to the. I have connected the output of the preset to the 3rd pin of the LM358. Now I'm going to connect the negative pin of the photodiode to the second pin of LM358. So I'm done with this. I have connected the negative pin of the photodiode with the second pin. I connected the negative pin of the photodiode with the second pin of the LM358 IC operational amplifier. So now what is remaining is the output. For seeing output, we are connecting this LED. For seeing output, we are connecting this LED with the first pin.
Of LM358, and now the ground of that with this.
As I switch on the power supply, you can see the LED is glowing, but as soon as I change the variable resistance, you can see it's changing, right? So on the peak point, I'll keep my variable resistance. Now you can see the proximity sensor, the magic. Now you can see as soon as I put my hand nearby it, in front of the LED, the light goes on, and as soon as I remove my hand, the light goes off. On, off, on, off, on, off. Okay, you can see both of my hands. I'm doing nothing over here, right? Both of my hands are over here. So as soon as I on, off. Now, so how is that? Proximity sensor is done with that. Okay, let's see again. Okay, is it the sensor? As soon as I keep my hand above, as soon as I take my hands, it's on, otherwise off. On, off, on, off, on, off. Sometimes when you make this project in sunlight, there are IA radiations from sunlight coming over here, and this II LED also emit II radiations, so it affects sometimes. So you have to keep up with the value of preset. Again, I'll show you. This is on, off. This is on, off. This is on, off. This is on, off. On, off. On, off. On, off. This is on. This is on. Off. So, are you done with that? Here it is, the proximity sensor today, and tomorrow I will come with a new project, and that will be more funnier than, you'll enjoy more than this. Tomorrow I'll come with a new project and you will enjoy more than this, I bet on that.